on Modern Marvels. The campus at Cisco Systems in Palo Alto, California. Home to one of the largest companies in the world. Behind these walls is enough wire to hook up an entire city.
The company today consists of almost 40,000 people. We sell $25 billion of products a year. And most of the world's internet traffic passes through our routers and switches on its way from its source to its destination.
These routers are Cisco Systems' bread and butter. They take files disassembled at the computer and route them through the network. Sometimes these chunks of information, called packets, take different paths to the same destination, depending on their need for bandwidth. At the destination, another computer reassembles the chunks back into the original file.
A router is sort of like a post office. When the different computers send out information, that information is addressed to another computer. But where is that computer? It could be anywhere in the world. And the router looks at the address and says, oh, this one is going to China, and starts shipping it off to China.
In one building, Cisco engineers have wired banks of routers together to create an experimental virtual post office of the future.
We have the world's largest router. That router can pass 93 terabytes of information. So that's almost a mind-boggling amount of information. To give you some sense of what that means, it's like transmitting the entire contents of the Library of Congress in 5 seconds.
While Cisco wasn't the first company to develop and sell a router, it did create the first commercially successful multi-protocol router to allow previously incompatible computers to communicate using different network protocols. This rapid movement of information by wire got its start a little earlier than most people realize.
With power such as the greatest hydroelectric station contributes to the scientific and propaganda sensation of the year.
The seeds of today's internet were sown in 1957, when Russia beat the Americans to space with the first satellite.
The Russians caught the United States by surprise by launching Sputnik. President Eisenhower said, "We will never again be caught with our pants down that way."
An agency was created in the Department of Defense called the Advanced Research Projects Agency, or ARPA. One of the areas it supported was computer science.
But what ARPA was promoting was this radical idea that a computer could interact with you in real time, that a computer could enhance human creativity, that a computer could be a portal to a world of information.
ARPA funded computer research at the country's top universities. UCLA professor Len Kleinrock was at the right place at the right time with a very smart plan. He created a program to divide computer messages into packets.
As a graduate student at MIT, I looked around me and I saw these computers. There were lots of them, but they were not able to talk to each other. There was no mechanism, no technology by which they could exchange data and communicate. I said, there needs to be a technology which supports that.
Kleinrock developed the fundamental principles that allow computers to speak directly over long distances. The wire system used to jumpstart the internet was already in place.
We could use any kind of wire, but the wires in the ground, you know, the United States is a copper mine. It's full of telephone wires. So why not use those wires for computers that are not physically next to each other? Use the telephone network, but change the switches at the end of those copper wires. So instead of using a circuit switches, which is the way we use telephones, introduce a new kind of switch. We eventually called that a packet switch, which allowed this rapid exchange of data dynamically.
Circuit switching delivers information in real time, and in the order it's sent on a dedicated line. Packet switching can use many lines to deliver information when real time isn't an issue.
So here we have my old friend, the first piece of networking equipment ever on the internet. I think it's beautiful, you may not. It looks like a large telephone booth. It's called an interface message processor. IMP number 1, inside, the most beautiful piece of machinery you've ever seen. Its ugliness is beautiful to me. This was the original switch of the internet. And here That is the CPU. There's less power here than in my watch right now.
The very first internet message traveled from UCLA in Los Angeles to the Stanford Research Institute in Northern California.
The first line, the first wire in the internet ever was attached between these two switches. The only message we wanted to send was to log in between these two machines. So Charlie typed the L, got the L. Type the O, got the O. Type the G, you get the G, crash. This system failed. So the very first message on the internet ever was low. Lo and behold.
Just as the telephone started on telegraph wires but quickly outgrew them, the computer is now maturing past the simple twisted pairs that served the telephone so well for more than a century. Receiving information at the speed of light would require wires that transport information as light. Len Kleinrock claims he committed the first illegal act on the internet in 1973, when he made an online request for the return of his electric razor from a conference in England. At that time, personal use of the internet was forbidden. Wiring America will return on Modern Marvels.